Product development, walking a tightrope. Introducing pathfinding. Product development walks a very fine line between over-design, leading to significantly higher cost, and under-design, risking failure of their entire program. Either can lead to a market failure. In addition, time-to-market pressures continue to mount as competitors nip away at their feet, causing additional pressure. Although they see their pot of gold at the end of the tightrope, it is very difficult to achieve. The question is how to lower their risks. Product development is expensive. Missing functionality, performance, or cost targets are all expensive. Respins are expensive. Missing a market window is expensive. And probably the most damaging is missing a company's quarterly projections for Wall Street. In order to solve this, we need to understand what is required to help us. We need a solution that is accurate and fast, that can evaluate many potential solutions long before we invest limited resources on very expensive implementation. In addition, there are many aspects that need to be investigated. 2.5 versus 3D versus classical PCB IC design, whether silicon or glass interposers can be used, how signal and power grounds are assigned to minimize noise. The list goes on and on and on. All these risks need to be evaluated by development team. Many product developers resort to using over-the-counter medication to help them get through this development. This is not the way to solve. In today's environment, we need to prescribe a new methodology to resolve this issue. The solution is simple. We need to insert a new capability early in our design flow that allows us to explore a huge solution space. The solution is called pathfinding. Pathfinding complements virtual prototyping and has been used for a long time. Since pathfinding is very early in the process, creating test cases must be fast without relying on implementation tools or their data. Pathfinding helps define rules, guidelines, how to manufacture, etc. Plenty of areas that pathfinding can be applied for silicon, PCB, or even system-level exploration. An article in GSA Forum's June issue discusses interconnect pathfinding. Let's see how pathfinding can be inserted into a development flow. From a 100,000-foot view, typically there are 4 key areas: architecture, silicon, system board design, followed by manufacturing that integrates the entire product. We can split this into 2 sections. One is the implementation that is fairly well known and includes physical verification. The other is exploration, which is primarily focused on virtual prototyping. Exploration has the biggest impact on an end product. Cost, power, area, performance, functionality, etc. can all be dramatically optimized or destroyed long before implementation begins. Pathfinding is a natural fit in the exploration phase to complement virtual prototyping. Virtual prototyping focuses on hardware-software trade-offs, while pathfinding can focus on electrical, thermal, mechanical trade-offs. Both are required for a successful product. Pathfinding is only limited by your imagination. Let me introduce Sphinx 3D Pathfinder. 3DPF is focused on electrical pathfinding. It has been created specifically for pathfinding and is good across many different capabilities. Some commercial solutions can provide a few of these capabilities, but they quickly fall down on other aspects that are critical to pathfinding. These tools were not targeted for pathfinding. They were targeted for final verification after a design has been implemented. 3DPF was specifically created to accelerate exploration to minimize implementation risks. For a more in-depth discussion on 3D Pathfinder, please see the video 3D Pathfinder. If you want to read more about pathfinding, here's a list of books and papers that have been published. In addition, more information can be seen on our website at www.e-systemdesign.com. Thank you.